Hi everyone. Today we are going to discuss one of the important topic of trigonometry, that is inverse trigonometric functions. Right. Okay, in this chapter we will discuss what is the inverse of a function, which type of functions have inverse, verify whether the trigonometric functions are bisective or not. If the functions are not bisective, how to define inverse of trigonometric functions? Right. Okay. Now, the monotonicity of inverse trigonometric functions and the various applications of trigonometric functions. Right. Okay. The important points in this chapter are: the first one is define inverse of a trigonometric function. Second one, graphs of inverse trigonometric functions. Third one, properties of inverse trigonometric functions. Right. Okay. First one, what is inverse of a function? Okay. The inverse of a function is the image of a function with respect to the line y is equal to x. That is the inverse of a function. Okay. Now, second question is, which type of functions have inverse? Right? Okay. For getting answer to this question, see some examples. Right. Example 1. Let f mapping from n to n defined by f of x is equal to 2x plus 3 is a linear function. Okay, this is a function. Now, verify this function is 1, 1 or onto. Right. For that, range is equal to f of n, that is equal to f of 1, f of 2, f of 3 and so on. Right. That is equal to set containing 5, 7, 9, 11 and so on. Therefore, distinct elements in a domain have distinct images in codomain. So, clearly the function is 1, 1. Right. So, this is range. This is equal to codomain or not equal to codomain. It is clearly not equal to codomain. Therefore, f is 1, 1 but not onto. Right. In this situation, we define inverse relation of this function. Right. For let f of x is equal to 2x plus 3 is equal to y. From this, we get x is equal to y minus 3 by 2. This is the inverse relation of given function. Now, g mapping from n to n defined by g of x is equal to x minus 3 by 2. Now, this is a relation. Now, verify this relation is a function or not. Right. For that, finding g of 1. G of 1, that is equal to g of 1 equal to 1 minus 3 by 2. That is equal to minus 1. Right. Minus 1 does not belong to n, that is codomain. Therefore, 1 has no image in the codomain. 1 has no image in the codomain. Therefore, G is not a function. G is just a relation. It is not a function. So, in this case, we can't define inverse of a function. Okay, now see another example. Let f mapping from R to closed interval 0 comma infinity defined by f of x equal to x square. Clearly, this is a function. Now, this function is 1 1 R onto. Okay, verify. Right. For that, f of minus 1 is equal to f of 1 that is equal to 1, since the function is an even function, and f of x is a non-negative function. From this, distinct elements have same image. Therefore, f is not 1 1, and the function is non-negative. Range is equal to closed interval 0 comma infinity. Therefore, the given function is not 1 1 and onto. Right. In this case, also we define inverse relation of f. For that, x square is equal to y, that implies x plus or minus root y. Now, G mapping from closed interval 0 comma infinity to R. Observe that here f mapping from A to B, G mapping from B to A. Right. This relation is defined by G of x equal to plus or minus root x. Okay. In this situation, this is only a relation. Now verify this relation is a function or not. After that, if it is a function, verifying 1 1 and onto property. Right. Okay. For that, we find G of 1, that is equal to plus or minus 1. Right. 1 has two images. 1 has two images in the codomain. Okay. For every function is a single valued function, so that it is not a function. Right. In this case also, G is just a relation but not a function. So, in this case also, we can't define inverse of a given function. Right. Okay, in this situation, how to define inverse of a function? What are the requirements for defining inverse of a function? Okay, right. Suppose the domain is restricted from capital R to closed interval 0 comma infinity in the same function. Okay, see that let f mapping from closed interval 0 comma infinity to closed interval 0 comma infinity defined by f of x equal to x square. Right. Clearly, f is both 1 1 and onto. Clearly, f is both 1 1 and onto. Right. In this case also, we define inverse relation of f, that is x square is equal to y, x equal to root y. Let G mapping from closed interval 0 comma infinity to closed interval 0 comma infinity defined by g of x is equal to root x, right? Clearly, g is a function. Clearly, g is a function and 1 1 and onto, right? Also, g circle f of x is equal to f circle g of x is equal to x, right? From this, we conclude that only bisective functions have inverses. Only bisective functions have inverses, right? Now, okay, from the above examples, we can conclude that if A comma B are the two sets and F mapping from A to B is a bisection, then G mapping from B to A is the inverse if G circle F is equal to IA and F circle G is equal to IB, right? Okay. Now, see the domains and ranges of trigonometric functions. Also, verify these functions are bisective or not, right? See the domains and ranges of trigonometric functions in the table, right? Here, sine and cos is defined for all real numbers. So, its domain is R. Tan, okay, tan is equal to sine by cos. The function tan is equal to tan theta is equal to sine theta divided by cos theta, right? Okay, the domain of tan theta is first, for what values of theta the denominator is 0. First find the values of theta. Okay, if the denominator is 0, right? That implies theta is equal to 2n plus 1 into pi by 2. Theta is equal to 2n plus 1 into pi by 2. That is odd multiple of pi by 2 where n belong to z. Now, the domain of tan and secant is same. Okay, that is set of all real numbers excluding the values at which cos theta is equal to 0. That is, the domain of tan and secant is set of all real numbers except the numbers is of the form 2n plus 1 into pi by 2 where n belong to z, right? Similarly, the domains of cot and cosecant are same. Cot theta that is equal to cos theta divided by sin theta, cos theta by sin theta. The domain of cot theta is set of all real numbers excluding the values of theta at which sin theta is equal to 0. That is, the domain of cot and cosecant is set of all real numbers excluding the numbers is of the form n pi where n belong to z. Okay, the ranges of trigonometric functions are already familiar. Okay, right? See now that from the domains of trigonometric functions observe that sin 30 degrees is equal to sin 150 degrees, cos 60 is equal to cos 120, tan 45 degrees is equal to tan 135 degrees. Okay, also draw a graph of sine function in the interval 0 comma pi. 0, pi by 2, pi, right? Sine 0 value 0, sine pi by 2 is 1, sine pi is equal to 0. The graph of sine theta is this, okay, right. Now verifying these functions are 1, 1 on 2, right. For verifying 1, 1 function, draw a horizontal line, Okay, if the horizontal line intersects the graph at only one point, then the function is 1, 1. Okay, otherwise it is not 1, 1, right. Here the horizontal line intersect the graph at 2 points in particular interval 0 comma pi. Therefore, sin theta is not 1, 1. Similarly, all trigonometric functions are not 1, 1. Okay, and hence the functions are not bisective. Now, we restrict their domains such that they are bisections. Okay, for the actual domains, the trigonometric functions are not bisective. For the defining inverse, we restrict their domains such that they are bisections. Okay, right. For any t belong to closed interval -1 comma 1, there exists unique x belong to closed interval -pi by 2 comma pi by 2 such that f of x is equal to 2. Okay, right. Also, closed interval -pi by 2 comma pi by 2 is a subinterval of largest length on which sine function is bisective. Okay, this also can be seen from the graph. Okay, see the graph of sin x. This is -pi by 2 and pi by 2, right. Sin -pi by 2 is equal to -1 plus 1. Now the graph is this, right. For any t belong to closed interval -1 comma 1, for any t belong to closed interval -1 comma 1, there exists unique x belong to closed interval -pi by 2 comma such that f of x is equal to t, right. Right, now see the restricted domains of trigonometric functions, right. Okay, see the domains. Observe that the domains of sine, tan and cosecant are same. Observe that the domains of sine, tan and cosecant are same. The domain is closed interval -pi by 2 comma pi by 2. Okay, the domain is closed interval -pi by 2 comma pi by 2, right. This is the domain of tan and cosecant, but tan is not defined at minus pi by 2 and pi by 2. So we take open interval. Okay. Cosecant is not defined at 0. Therefore, delete 0 from closed interval minus pi by 2 comma pi by 2. Right. The domain of sine, tan and cosecant are same except some values at which the function is not defined. Okay. Similarly, the domain of cos, cot and secant are same. That is closed interval 0 comma pi. That is closed interval 0 comma pi. Right. So, cot is not defined at x equal to 0 comma pi. Therefore, the domain of cot is open interval 0 comma pi. Okay. Secant is also not defined at x is equal to pi by 2. So, pi by 2 is deleted from closed interval 0 comma pi. Okay. So, the ranges is same. Right. In these domains, all the trigonometric functions are 1-to-1 and hence they are bisections. Right. So, now we define inverse of trigonometric functions. Right. The function sine inverse mapping from closed interval minus 1 comma 1 to closed interval minus pi by 2 comma pi by 2 defined by sine inverse x is equal to theta if and only if theta belong to closed interval minus pi by 2 comma pi by 2 and sine theta is equal to x for all x belongs to closed interval minus 1 comma 1 is called the inverse sine function. This function is also denoted by arc sine. This function is also denoted by arc sine. Similarly, we can define the remaining trigonometric functions, okay, based on their domain. Okay. Right. Now, the domains and the ranges of inverse trigonometric functions. Right. Okay. Sine inverse, cos inverse, the domain for these two functions is same, that is closed interval minus 1 comma 1. Okay, this is a real line. This is a real line. This is a real line minus infinity to infinity, minus infinity to infinity. The domain of sine inverse and cos inverse is closed interval minus 1 comma 1. The domain of tan inverse x and cot inverse x is entire real line. The domain of tan inverse and cot inverse is entire real line. And the domains of secant inverse x and cosecant inverse is real line except closed interval minus 1 comma 1. The domain of secant inverse and cosecant inverse is minus infinity to closed interval minus 1 union closed interval 1 comma infinity. The domain of secant inverse and cosecant inverse is open interval minus infinity comma closed interval minus 1 union closed interval infinity. Okay. Also, if f defined from a to b, then the inverse functions defined from b to a. Right? Once again, if a function defined from a to b, then its inverse functions defined from b to a. Right? Okay. In this way, the domains and ranges are defined for inverse trigonometric functions. Okay. Right, now see the graphs of inverse trigonometric functions. Right, first one, draw the graph of y is equal to inverse x. Draw the graph of y is equal to sine inverse x. What is the domain of sine inverse? Domain of sine inverse, that is closed interval minus 1 comma 1. Range of this function, range of sine inverse, that is closed interval minus pi by 2 comma pi by 2. Right. By taking the domain values on x-axis and range values on y-axis. Right. If x increases from minus 1 to 1, then sine inverse x increases from minus pi by 2 to pi. Therefore, sine inverse x is an increasing function. Increasing function is denoted like this. Right. Now, draw the graph of y is equal to cos inverse x. Y is equal to cos inverse x. The domain of this function is same, closed interval minus 1 comma 1. Range is closed interval 0 comma pi. Right, range is equal to closed interval 0 comma pi. Right, by taking the domain values on x-axis and range values on y-axis. If x increases from minus 1 to 1, then cos inverse x decreases from pi to 0. Then cos inverse x is a decreasing function. Cos inverse x is a decreasing function. Decreasing function is denoted like this. Okay. Now see the graph of tan inverse x. The domain of tan inverse x is domain of tan inverse x, that is set of all real numbers. Now range of tan inverse x, range of tan inverse x, that is open interval minus pi by 2 comma pi by 2, that is the range. Right. By taking the domain values on x-axis and range values on y-axis. Right. Here tan pi by 2, tan minus pi by 2 are not defined. So we draw a horizontal asymptotes. These two are called asymptotes. Right. If x increases from minus infinity to infinity, then tan inverse x increases from minus pi by 2 to pi by 2. If x increases from minus infinity to infinity, then tan inverse x increases from minus pi by 2 to pi by 2. Right. Now see the graph of y is equal to cot inverse x. the domain of cot inverse x, domain of cot inverse x is set of all real numbers. Range is equal to open interval 0 comma pi, open interval 0 comma pi. Take the domain values on x-axis and range values on y-axis. Right. Here also cot 0 and cot pi are not defined. So we draw a horizontal asymptotes. These two are called asymptotes. Right. This is also asymptote. Right. If x increases from minus infinity to infinity, then cot inverse x decreases from pi to 0. Therefore, cot inverse x is a decreasing function. Cot inverse x is a decreasing function. Right. Now, see the graph of secant inverse x, the domain of secant inverse x. What is the domain of secant inverse x? Open interval minus infinity comma minus 1 union closed interval 1 comma infinity. Range of secant inverse x. Range is equal to closed interval 0 comma pi excluding singleton set pi by 2. Now, by taking the domain values on x-axis and range values on y-axis, right? If x increases from minus infinity comma minus 1, then secant inverse x increases from pi by 2 to pi, and x increases from 1 to infinity, then secant inverse x increases from 0 to pi by 2, right? So, from this, secant inverse x is also an increasing function, right? Now, see the graph of cosecant inverse x. The domain of cosecant inverse x is domain of this function minus infinity comma minus 1 union closed interval 1 comma infinity. Range that is equal to closed interval minus pi by 2 comma pi by 2 excluding singleton set 0, right? By taking the domain values on x-axis and range values on y-axis, right? Okay, here x increases from minus infinity to minus 1, then cosecant inverse x decreases from 0 to minus pi by 2. If x increases from 1 to infinity, then cosecant inverse x decreases from pi by 2 to 0. Therefore, cosecant inverse x is a decreasing function. Cosecant inverse x is a decreasing function, right? These are the graphs of inverse trigonometric functions, right? Now, the properties of inverse trigonometric functions are various applications of inverse trigonometric functions, right? See the properties, how to change the properties of inverse functions related to trigonometric functions, right? See a theorem for x belong to closed interval minus 1 comma 1 except 0, right? This theorem shows that what is the relation between sine inverse and cosecant inverse. What is the relation between sine inverse and cosecant inverse? Right, from plane trigonometry, cosecant theta is equal to 1 by sine theta. Secant theta is equal to 1 by cos theta. Okay, right. Okay, from those properties, here cosecant inverse 1 by x, cosecant inverse 1 by x is equal to sine inverse x. Now, cos inverse x in terms of secant inverse, that is secant inverse 1 by x. Okay, right. Now, cot inverse x, that is equal to tan inverse 1 by x. Right. This is true for only x greater than 0. This is true for x greater than 0. Okay, if x less than 0, if x less than 0, what is the value of cot inverse x in terms of tan inverse? Right? See, if x less than 0, what is the value of cot inverse in terms of tan inverse? Right, cot inverse x is equal to pi plus tan inverse 1 by x. Right, this is true for all x belong to closed interval minus 1 comma 1 0, but here there are two cases. For x greater than 0 is one case, second case is x less than 0. If x less than 0, cot inverse x is equal to pi plus tan inverse 1 by x. Right? How to prove this? Right? Let tan inverse 1 by x is equal to theta. Here x less than 0. That implies theta belongs to open interval minus pi by 2 comma 0. X less than 0 means minus infinity less than x less than 0. Right? Apply tan inverse minus infinity, tan inverse 1 by x is also tan 0, tan inverse minus infinity is minus pi by 2 less than tan inverse 1 by x less than tan inverse 0, that is equal to 0. Right? Theta belongs to open interval minus pi by 2 comma 0 and tan theta is equal to 1 by x. That implies cot theta is equal to x. That implies pi plus theta belongs to close open interval pi by 2 comma pi, pi plus theta belong to open interval pi by 2 comma pi, and cot theta is equal to cot of pi plus theta. Right? Here cot of pi plus theta is equal to x, and also pi plus theta belongs to the domain of cot. By the definition of inverse trigonometric functions, that implies pi plus theta is equal to cot inverse x. Pi plus theta equal to cot inverse x. That implies cot inverse x is equal to pi plus tan inverse 1 by x. Pi plus tan inverse 1 by x. Right? If x less than 0, cot inverse x is equal to pi plus tan inverse 1 by x. Right? Okay, see a small example. Okay, set A and set B. Set A contain two elements A and set B contains two elements P and Q. Right? P is the image of A, Q is the image of B. Clearly, f is a bisective function. Okay, now we define inverse of f inverse mapping from B to A. Right, f inverse mapping from B to A. Okay, now what is the value of f inverse of f of x is equal to? What is the value of f inverse of f of x is equal to? Right. Okay, from the diagram f of a is equal to p and f inverse of p is equal to a. Right. Okay, substitute the value of p in this, we get f inverse of f of a is equal to a. Right. Similarly, f inverse of f of b is equal to b. Right. Here f inverse of f of a is equal to a, f inverse of f of b is equal to b. Right. From this we conclude that f inverse of f of x is equal to x. f inverse of f of x equal to x. Right. Okay. From the example we can conclude that f inverse of is equal to x. Similarly, we can prove that f of f inverse of x, f of f inverse of x is equal to x. Right. Now, what is the value of sine inverse of sine theta, cos inverse of cos theta, tan inverse of tan theta? Right. See the theorem. What are the values? Right. For theta belong to closed interval minus pi by 2 comma pi by 2, the value of sine inverse of sine theta is equal to theta. For x belong to closed interval minus 1 comma 1, sine of sine inverse x is equal to x. Theta belong to closed interval minus pi by 2 comma pi by 2 and assume that sin theta is equal to x. Right? Theta belong to closed interval minus pi by 2 comma pi by 2. Sin theta belong to closed interval minus 1 comma 1. That implies x belong to closed interval minus 1 comma 1. Hence, right, sin inverse x is equal to theta. That implies sin inverse of sin theta is equal to x. Right. Similarly, cos inverse of cos theta, that is equal to theta, and cos of cos inverse is equal to x. Tan inverse of tan theta is equal to theta, and if x belong to R, then tan of tan inverse x is equal to x. Thank you.